Record.
Okay. Assalamualaikum and hi to Dr. Rosmina. My name is WAHIDAH binti IDHAM KHALID. My matrix number is 2121.
Okay, hello. A very good day to Dr. Rosmina and my fellow classmates. My name is Junam Kun, number matrix 212552. We are from group 11 and we are going to present a topic of carbonization. Okay. Okay, have you ever wondered how does wood turn into charcoal? Yes, it is through the process of carbonization. Okay. Carbonization is the term used to when a complex carbonaceous substance such as wood or agricultural residue are broken down by heating without presence of oxygen into elemental carbon and chemical compound, which may also contain some carbon in their chemical structure. Okay. There are mainly two types of carbonization depending upon the temperature up to which the coal is heated in absence of air. Number one is low temperature carbonization, known as LTC, and high temperature carbonization, known as HTC. Okay, low temperature carbonization is a method of processing solid fuels by heating without access to air to 500 to 700 degrees Celsius, producing low temperature coke and volatile products, or known as soft coke. As a main application is for smokeless fuel and for domestic and industrial usage. Okay, well, for high temperature carbonization, it is a method of processing solid fuels by heating without access to air at a temperature which is above 900 degrees Celsius, producing metallurgical coke for use in blast furnace or main foundry. And the main application for this is production of calcium carbide, electrode carbon, metallurgical coke. Okay, and in this photo, we can see the black carbon electrode in this dry battery is a product of high temperature carbonization. And this diagram is the metallurgical coke manufacturing process. Next, I will pass to my partner, NURUL WAHIDAH, to present.
I will tell you about hydrothermal carbonization. It is a chemical process for the conversion of organic compounds to structured carbons, and the process is conducted at temperature generally between 118 and 300 Celsius, which with corresponding pressure above 10 to 88 bar to ensure that the water is maintained in the liquid state. Reaction times ranging between 0.1 and 4H have been employed. The particular temperature, pressure, and time setting chosen rely on the calibre of the feed sludge, as well as the desired yield and properties of the hydrochar products. Next. This is a visual of hydrothermal carbonization. Okay, next. I will tell you about the materials and methods of carbonization process. This is a visual of kilns. And the visual of the retorts. Okay, I will show you about the materials and methods of carbonization process through this YouTube video.
Okay, here is a sample video of carbonization. Okay, in this carbonization reactor, is a retort. Okay, first we can see the materials such as coconut shell. Okay, this coconut shell, wood sticks, briquettes, it will be loaded into the retort first. This is the material used in this carbonization reactor. Okay. In retort, heat is generated from an external heat source. Then it will transfer the heat to the biomass by different means which are direct heating. The hot gas passes through the reactor and comes in contact with the biomass. Okay, you can see it is being heated up. Indirect heating, where the heat from the hot gas are transferred to the biomass through the retort wall. The advantage of retort over kiln is that there's no partial combustion for the biomass inside the reactor, which will increase the output of the char fuel. Okay, then after that, we can see the process of cooling. Okay, after the product is being carbonized, it will be packaged, and then you will only sell afterwards, sell to the market. Okay, for the next slides, I will talk about the process of carbonization. Okay, the first step of carbonization process is pre-drying, where the biomass is heated from room temperature to the drying temperature, which is approximately 100 degrees Celsius. During this stage, the heat is mostly transferred by conduction from a reactor walls to the biomass. Then the second step is drying. This step is the highest step in energy consumption because all the heat supplied during this stage is just to convert the moisture content in the biomass from the liquid to the vapor phase. After drying is complete, the heat energy is added to the biomass and it will start to increase its temperature, which is known as post-drying. Next is the process. The next process is low temperature carbonization and followed by high temperature carbonization, depending on the product we are making. If the purpose of produce is to produce activated carbon for absorption, the heating continues until 800 degrees Celsius in superheated steam to remove the tar. Thus, it will undergo a process known as activation. Then, the final step in process line is cooling. If the product is removed from the reactor exactly after the carbonization ends, it will burn off and ignite. Because the reactor final temperature is much higher than the ignition temperature of the produced charcoal. So it must be cooled first before it exposed to the oxidative atmosphere. Next, I'll pass to Wahidah to explain on the products of carbonization.
Okay, I will tell you about the example of product of carbonization. First is charcoal, which is it can produce fuel. Next, second is activated charcoal. Next is biochar, which we can use it as a fertilizer. And biocoke. That's all.
Okay, that's all from our Group 11 presentation. Okay, thank you.